When it comes to understanding the universe, we are only beginning. Humankind continually searches for patterns, trying to figure out, what is the universe made of? How does it work? How does our planet, our solar system, our galaxy fit in with the other pieces? And what don't we know yet? Helping us discover more pieces of the puzzle will be a new instrument on board the International Space Station called the Alpha Magnetic Spectrometer, or AMS. AMS is not a telescope. Rather than looking at space, it will sift through space, studying the high-energy particles of cosmic rays. From the unique vantage point of Earth orbit, the AMS experiment has the potential to answer questions about the origins of our universe. It began with a bang. The Big Bang Theory postulates that the universe was created in a great explosion. But there are some puzzle pieces missing regarding the Big Bang. During this explosion, matter and antimatter should have been created in equal amounts. But we have a hard time finding the antimatter in the universe. Where is it, and what exactly is the universe made of? We don't know for certain yet. Here's another missing piece. Astronomers have determined that galaxies have 10 times the mass than what we see of stars, gas, and dust. What accounts for this missing mass in galaxies? The answer may be dark matter, a mysterious material that exerts gravitational pull but does not absorb or emit light. But we have yet to find dark matter. The study of high-energy particles might help in the search for dark matter and antimatter in the universe. Nobel Prize-winning scientist Professor Samuel Ting, well known for groundbreaking particle physics work on Earth, has collaborated with an international team to create the Alpha Magnetic Spectrometer, a high-energy particle detector that takes particle science into space. He and his colleagues hope the AMS will help answer some of these nagging questions about the universe.
If the universe has come from a Big Bang, and so you have matter, you must have antimatter. Now the universe is close to 15 billion years old. The question is, where is the other half? Where is the universe made out of antimatter?
An alpha magnetic spectrometer flew on board the space shuttle in the 1990s, but that mission was only for a few days, merely proving the concept of flying this type of hardware in space. While valuable science was gleaned from that mission, the AMS on the station will stay for years, with instrumentation that is far more sensitive and far more precise than what was flown before. With over 300,000 data channels for detection and over 600 onboard microprocessors to analyze the data. The AMS is sponsored by the Department of Energy, and scientists from 16 countries lent their expertise to create it. Parts from around the world were sent to CERN, the European Organization for Nuclear Research, in Geneva, Switzerland. NASA had the job to figure out how to get the 15,000-pound experiment into Earth orbit and have it operate in the hostile environment of space. The AMS was finally sent to the Kennedy Space Center, where it was ready to fly on board a space shuttle, the final large component of the space station to be sent on one of the last shuttle flights. Part of the shuttle crew is European Space Agency astronaut Roberto Vittori, who will operate the shuttle arm to grasp the AMS from the shuttle payload bay.
That means that I will have the responsibility with the shuttle robotic arm to take it from the payload bay and offer to the station. But behind that specific operational task, there is a very long history. I started about 20-25 years ago to study physics, to think about space, to think about the universe. And the specific of the search of the antimatter was one of my main and deep interests. It may appear as a very strange coincidence that today I will be the one to take this unique piece of hardware, take it from the bay of the shuttle, and give it to install on the station.
For the AMS, there are many benefits to having a fully functional space station as your home.
So AMS weighs 15,300 pounds. Most of that is science experiments. We do not have to carry our own power. We do not have to carry our own data systems to transmit that data back to Earth, because all of those systems are provided to us by the space station. It's a perfect example of how you can utilize the capabilities of the International Space Station to fly groundbreaking science experiments.
So how exactly does the AMS work? One thing it is not is a telescope. Telescopes measure photons, packages of light, both visible and invisible to the naked eye. This type of astronomy has given us most of our knowledge of the universe thus far. But the cosmos speaks to us in languages other than light. For the AMS, this will be the first time scientists study charged particles. Exploding stars and other celestial phenomena are thought to produce cosmic rays which travel across the universe and can wash up on the shores of our planet. The rays are composed of charged particles, but many of these are absorbed in our atmosphere, making it impossible to study them on Earth. But outside our atmosphere, on the space station, the AMS will be able to sift through these particles, helping us search for antimatter, dark matter, and the stuff of which the universe is made. A particle will pass into the AMS. Layer upon layer of detectors tells us the mass, energy, and velocity of the particle. Other detectors tell us which direction or path the particle took as it passed through the AMS. At the heart of the unit is a magnet that will make the particle curve one way or another, telling us whether it is matter or antimatter. And just how quickly does all this particle detection happen?
Faster than I can snap my fingers. Nanoseconds. In nanoseconds. AMS gathers data at a ridiculously large rate. We will see about 25,000 hits per second of cosmic rays coming into the aperture of AMS.
If, while sifting through the cosmic sands, the AMS strikes gold, 2 star trackers on board the experiment will help scientists determine from where in the universe the particle came. The AMS can send its volumes of data utilizing the station's communication link with Earth. Teams of scientists all over the world will study that data, looking for particles of dark matter, antimatter, and the unknown. So what will we find? Nobody knows. In the science of particle physics, anything is possible, and often the quest for one answer instead reveals another discovery not dreamed of. If the cosmos is the ultimate particle accelerator, it should provide plenty for the AMS to analyze. The experiment will stay on board the space station for as long as the station is in orbit, silently sifting through the particles, helping scientists find those missing pieces to the puzzle of our universe, and perhaps finding something new for us to explore along the way.